Now in this lecture we'll find out the area of the green shape. In the drawing we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have this green shape. And our mission is to find out the area of this green shape. Actually the green shape is a right triangle, triangle DCB. Because angle DCB equals to 90 degrees in size, and our mission actually is to find out the area of this right triangle, triangle DCB. In addition, we know that side OB equals to 2 units in its length, side AD equals to side DO. Again, our mission is to find out the area of the green shape, that is actually the area of the right triangle, triangle DCB, because angle DCB equals to 90 degrees in its size. Okay, so first of all, we know that AOB is a quarter circle, therefore angle AOB, this angle AOB equals to 90 degrees in its size. Side OB equals to side OA. They are both the radii of this quarter circle, and therefore they are equal to each other. But side OB equals to 2 units. That means that the area of this quarter circle equals to 2 units in its length, therefore AO, that is also the radius of this quarter circle, is also equals to 2 units in its length. We know that line segment AD equals to line segment DO. So if we define the length of this line segment AD as X, then the length of line segment DO must be also equal to X because they are equal to each other. So AD plus DO equals to AO. AD is X, DO is X, therefore X plus X equals to 2. So write it down, X plus X equals to 2. X plus X is 2X, so 2X equals to 2. Here we divide this equation by 2, and we get that X equals to 2 over 2, that is 1. So AD is equal to X equals to 1 unit in its length. And DO, this is also equals to X, is equals to 1 unit in its length. In the next step, we'll copy the right triangle, triangle DOB in a new page, and we'll implement the Pythagoras theorem on this right triangle, triangle DOB. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is abbreviation for Pythagoras theorem. So actually, this is the right triangle, triangle DOB that according to the original drawing. According to the Pythagoras theorem, in this right triangle DOB, dB square equals to DO square plus OB square. Again, dB square equals to DO square plus OB square. So I write it down. dB square equals to DO square plus OB square. DB is the missing side, so we leave it as it is. So DB square equals to DO square. DO equals to 1, therefore DO square is 1 square, that is 1, plus OB square. OB equals to 2, therefore OB square is 2 square, that is 4. So in total, DB square equals to 1 plus 4, that is 5. So DB square equals to 5, we take out all of this equation, and we get that DB equals to the square root of 5 units in its length. Actually, this is side DB, and it is equals to the square root of 5 units in its length. In the next step, we will do a construction. That is to say, we will complete this quarter circle to a circle. So I actually completed the quarter circle to a circle. In the next step, we'll extend the radius BO by a straight line until it touches the circle. BO as a radius, it is absolutely a straight line. When extended the straight line BO by straight line, the result must be a straight line. So this is a straight line. We define the touching point of the extended straight line BO with this circle, this point as point P. Repeat again, when you extend the straight line by straight line, the result is a straight line, therefore BP is a straight line. If we focus on the upper side of the straight line PB at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BP at point O? We have this angle that is 90 degrees plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. We know that angle BCD equals to 90 degrees in its size. We'll extend side CD by a straight line until it touches the circle. Actually, by extending the straight line CD until it touches the circle, we create here a peripheral angle. And this peripheral angle equals to 90 degrees because angle BCD equals to 90 degrees. And according to rule 5, any peripheral angle that is equal to 90 degrees in its size must be subtended on the diameter of the circle. I repeat again on rule 5. According to rule 5, any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. So we have a peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in its size. And therefore this peripheral angle, according to this rule 5, must be subtended on the diameter of the circle. Actually, the diameter of the circle is MN. And it's very easy to see that, again, indeed, a peripheral angle MAN is subtended on MN, that is the diameter of the circle. We can actually implement rule 5 in our drawing. Why? Because in our drawing, after we extend the straight line CD until it touches the circle, we create peripheral angle BC, whatever, that is a right angle. So this peripheral angle must be subtended on the diameter of the circle because this angle equals to 90 degrees. And any peripheral angle that is equal to 90 degrees must be subtended on the diameter of the circle. So in order that this peripheral angle will be subtended on the diameter, the extended side CD must touch the circle at point P. Otherwise, if the extended side CD will not touch the circle at point P, if it touches the circle in any other point, it will be contradiction to rule 5. Because we have here peripheral angle that is equal to 90 degrees in its size, and still it doesn't subtend on the diameter of the circle. In order to avoid the contradiction to rule 5, the extended side CD must touch the circle at point P and at point P only. So now you can see that peripheral angle BCP equals to 90 degrees in its size and is subtended on PB, that is the diameter of the circle. But why PB is the diameter of the circle? Because we have here, we know that PB is a straight line because we extended the straight line BO by straight line. When you extend the straight line by straight line, the result is a straight line. So now we know that PB is a straight line and it touches the circle at 2 points, P and B. Any straight line that touches the circle at 2 points, it is a chord. So PB is a chord, but it is a chord that passes for point O, that is the center of the circle, and know that any chord that passes for the center of the circle must be the diameter of the circle. So PB is the diameter of the circle. So write it down. PB is the diameter of the circle. And because of the fact that peripheral angle BCP is equal to 90 degrees in its size, it must be subtended on the diameter of the circle. That is to say, it must be subtended on PB, that is the diameter of the circle. So you can see that if the extended side CD doesn't touch the circle exactly at point P, then it will be contradiction to rule 5, because we have a peripheral angle that is equal to 90 degrees in its size, and still it doesn't subtend it on the diameter of the circle. And in order to avoid contradiction to rule 5, this peripheral angle BCP must be subtended on the diameter of the circle only if peripheral angle BCP, if the extended side, only if the extended side D touches the circle at point P, then peripheral angle BCP will be subtended on PB, that is the diameter of the circle. Okay. Now I'll copy the right triangle PDO in a new page, and we'll implement the Pythagoras theorem on the right triangle PBO. Actually, you know that what is the length of line segment OP? Line segment OP starts from point O, that is the center of the circle, and then at point P, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, PO equals to 2 units in its length, that is the radius of the circle, therefore it is equal to 2 units in its length. So in the next step, I'll copy the right triangle PDO in a new page, and we'll implement the Pythagoras theorem on the right triangle PDO. Actually, you can see here that in the right triangle DOB, side BO equals to 2, side DO equals to 1, and therefore the hypotenuse equals to the square root of 5 units in itself. Likewise, we can see here that in the right triangle DOP, side PO equals to 2, side DO equals to 1, and therefore the missing side, that is the hypotenuse DP, must be also equal to the square root of 5 units in its length. Okay, anyway, we'll implement the Pythagoras theorem here again. Well, this is the right triangle PDO, there's a comment from the original drawing. Here by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, this right triangle PDO, PD square must be equal to DO square plus PO square. So PD square, that is the square of the hypotenuse, must be equal to DO square. DO is 1, therefore DO square is 1 squared, that is 1, plus PO square. PO is 2, therefore PO square is 2 squared, that is 4. So in total, PD square equals to, PD square equals to 4, so in total, PD square equals to 1 plus 4, that is 5. Here we take a root of this equation and get that PD equals to the square root of 5 units in its length. So this side PD also equals to the square root of 5 units in its length. In the next step, we'll do a construction, or we'll extend the radius AO by a straight line until it touches the circle. And we'll define the touching point of the extended radius AO with this circle. This point is point Q. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. This is exactly the definition for radius. Therefore OQ is the radius of this circle, that is equal to 2 units in its length. Here we can implement rule 11, and quickly on rule 11. According to rule 11 is true in any circle, so in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. Again, chord AB intersects with chord CD at point O. And therefore, the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule 11 in our drawing. Why? Because in our drawing, we have here chord AQ. This is chord AQ that intersects with chord CP. This is chord CP, and they intersect with each other at point D. Point D is the intersection point of chord AQ with chord CP. And therefore, so I write it down. Chord AQ intersects with chord CP at point D. Repeat again. Now drawing. Chord AQ the circuit code CP at point D. And therefore, according to rule 11, the following equation will be true. AD times DQ equals to CD times DP. Repeat again. According to rule 11, AD times DQ equals to CD times DP. AD is 1 times DQ. DQ in total, here DQ equals to 1 plus 2, that is 3. DQ equals to DO, that is 1, plus OQ, that is 2. So in total, DQ equals to 1 plus 2, that is 3. And it is equals to CD. CD is the missing side, so we leave it as it is. Times dp. dp equals to the square root of 5 units. So according to rule 11, we found out that 1 times 3 equals to cd times square root of 5. 1 times 3 is 3, so 3 equals to 5, square root of 5 times cd. Here we divide this equation by square root of 5, and you get that CD equals to 3 over square root of 5 units in its length. So actually, this is side CD that is equal to square root of equals to 3 over square root of 5 units. So I write it down. CD equals to 3 over square root of 5 units in its length. In the next step, I'll copy the right-hand triangle CDB in a new page and implement the Pythagoras theorem in this right triangle CDB in order to find out the length of the missing side CB. Here by PT is a version for Pythagoras theorem. Actually, this is right-hand triangle CDB that according to the original drawing. According to the Pythagoras theorem, this right triangle CDB, the square of the hypotenuse is dB square, and dB square must be equal to CD square plus CB square. So dB is equal to 5, therefore dB squared is equal to 5 squared, that is 5. And it is equal to CD squared. CD is 3 over square root of 5, therefore CD squared is 3 over square root of 5 squared. 3 over square root of 5 squared equals to 3 squared, that is 9, over square root of 5 squared, that is 5. So in total, 3 over square root of 5 squared equals to 9 over 5 plus CB squared. CB is a missing sign, so we leave it as it is. So I found out actually that 5 equals to 9 fifths plus CB squared. Here we subtract 9 fifths from this equation, and we get that five minus 9 fifths equals to CB squared. Here we multiply 5 by 5 and then we divide it by 5 in order to common factor with 9 over 5. So 5 times 5 is 25. So in total in the numerator we will have 25 minus 9 over 5. That is equal to CB squared. (25) minus 9 is 16, so in total this expression equals to 16 over 5 equals to CB squared. Here we take a root out of this equation and we get that CB equals to the square root of 6 is 4 over square root of 5. So CB equals to 4 over square root of 5 units in its length. So this is side CB, that is equals to 4 over square root of 5 units in its length. Our mission is to find out the area of the green triangle, the green right triangle DCB. So I copy the green right triangle DCB and find out the area of this green right triangle DCB. So actually, the area of the green shape is actually the area of the green right triangle DCB. So we have actually to find out the area of the green right triangle DCB. That is the area of the green shape. So actually, this is the right triangle DCB. The area of any triangle equals to the base of the triangle times the height to the base over 2. That is the area of any triangle, and the area of this green triangle, it is actually the area of the green shape. So you can write down that the area of this triangle is the area of the green shape, that is the area that we are looking for. So the area of the green shape equals to the base of this right triangle. We take the base as DC times the height to the base. The height to the base is CB. Why CB is the height to the base? Because it creates 90 degrees with the base. CD. So the height to the base is CB over 2. So the area of the green shape equals to DC, that is 3 over square root of 5, times CB, that is 4 over square root of 5 divided by 2. So here we have 4 times 3 is 12 over square root of 5 times square root of 5 is 5 divided by 2. 12 over 5 over 2 is 12 over 5 times 2. So it is 12 and 5 times 2 is 10. So therefore the green shape equals to 12 over 10. Here we divide both the numerator and the denominator of this number by 2. 12 over 2 is 6 and 10 over 2 is 5. 6/5 is 1.2. So actually found out that the area of the green shape, the area of this green shape equals to either 6/5 square units, or in terms of numbers, the area of this green shape equals to 1.2 square units. Okay, so in the next step I will summarize the lecture. So in this lecture we found out the area of this green shape. So in the drawing we have a quarter circle, AOB is a quarter circle. We know that side OB equals to 2 units in its length. 9 segment AD equals to 9 segment OD. And we also know that this angle is a right angle, and therefore our mission is actually to find out the area of the green right triangle DCB. Okay. So first of all, we know that AOB is a quarter circle, therefore this angle AOB equals to 90 degrees in its size. In addition, the radii of this quarter circle are the two sides AO and OB. But OB equals to 2, therefore the radius of this quarter circle is 2 units. Therefore AO, that is also the radius of the quarter circle, equals to 2 units in its length. We know that AD equals to DO. If we define AD as x, then DO must be also equal to x because they are equal to each other. AD plus DO equals to AB. AD plus DO equals to AO. AD is x, DO is x. Therefore, AD plus DO is x plus x. That is equal to AO. But AO is 2. Therefore, x plus x, that is 2x, equals to 2. Because AO is 2. Repeat again, x plus x equals to AO, that is 2. So, x plus x is 2x, so 2x equals to 2. Here we divided this equation by 2 and finally found out that x equals to 1. So AD that is equal to x equals to 1. And DO that is also equals to x according to our definition equals to 1 unit in its length. In the next step I copied this right white triangle DOB in a new page and we implemented the Pythagoras theorem of this white right triangle DOB. Actually, this is the white triangle DOB that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle DOB is DB, therefore the square of the hypotenuse is DB square, and it must be equal to DO square plus OB square. DB is the missing side of electricity, so DB square equals to DO square. DO is 1, therefore DO square is 1 square, that is 1. Plus OB square. OB is 2, therefore OB square is 2 square, that is 2. So in total, DB square equals to 1 plus 4, that is 5. So DB square equals to 5. Here we talk about all of this equation and finally found out that DB equals to the square root of 5 units in its length. Here, this is side DB, that is equal to the square root of 5 units in its length. In the next step, we did the construction. That is to say, we completed this quarter circle to a circle. Okay, and then We extended the radius BO by a straight line until it touches the circle. We define the touching point of the extended radius BO with this circle. This point is P. So BO is a radius, it is absolutely a straight line. When you extend a straight line by a straight line, the result is a straight line. So the result BP must be also a straight line. But BP is a straight line that touches the circle at 2 points, B and P, therefore BP is defined as a chord. But BP is a chord that passes through point O, that is the center of the circle, and you know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore BOP is the diameter of the circle. If BOP is the diameter of the circle, it means that BP is the diameter of the circle. So if we found out that BP is the diameter of the circle. In the next step, we extended side CD by straight line until it touches the circle. And we have rule 5. According to rule 5, any peripheral by extended side CD until it touches the circle, we get a peripheral angle BCD that is equal to 90 degrees in its size, and according to rule 5, any peripheral angle that is equal to 90 degrees in its size must be subtended on the diameter of the circle. And therefore, this peripheral angle BC, whatever, must be subtended on the diameter of the circle. For that reason, it must the extended side CD must touch the circle at point P and only at point P. And in this way, we get peripheral angle BCP is equal to 90 degrees, and indeed it's subtended on PB, that is the diameter of the circle. Otherwise, if the extended side D will touch the circle at any other point, it means that we get contradiction to rule 5, because we'll have peripheral angle BC whatever that is equal to 90 degrees in its size and still is not subtended on the diameter of the circle, that is PB. In order to avoid contradiction, we must conclude that the extended side CD must touch the circle at point P and only at point P. And in this way, we get that peripheral angle BCP equals to 90 degrees in its size, and indeed it's subtended on PB, that is the diameter of the circle. Okay. In the next step, I copied here, what is the definition of line segment OP? Line segment OP starts from point O, that is the center of the circle, and that's at point P, that is the point of the circle itself. So this is exactly the definition of radius. Therefore, OP is the radius of the circle, that is equal to 2 units. In the next step, I copied the right triangle DOP. In the new page, we implemented the Pythagoras theorem on this right triangle DOP. This is the right triangle DOP that I copied from the original domain. According to the Pythagoras theorem, dB square equals to dO square plus OB square. So dB square equals to dO square. dO is 1, therefore dO square is 1 square, that is 1, plus OB square. OB is 2, therefore OB square is 2 square, that is 4. So in total, dB square equals to 1 plus 4, that is 5. Here we took out of this equation, and found out that dB equals to the square root of 5 units in its length. So this is side dB, this is side dB, actually this is side dB, it is equals to square root of 5 units in itself, but we actually implemented the Pythagoras theorem on the right triangle PDO. Repeat again, implemented the Pythagoras theorem on the right triangle PDO, and we actually found out that the hypotenuse PD equals to the square root of 5 units in its length, because it is exactly the same triangle. And here we found out that dB equals to the square root of 5 units in its length, therefore the hypotenuse dP must be also equal to the square root of 5 units in its length. So this is the hypotenuse dP, that is also must be equal to the square root of 5 units in its length, but those two triangles are congruent to each other. Side dB equals to the square root of 5 units in its length, therefore side dP must be also equal to the square root of 5 minutes in step because both of them are the hypotenuse of the right triangles and therefore they must be equal to each other. Okay. In the next step, I extended the radius AO by a straight line until it touches the circle. We define the touching point of the extended radius AO with this circle. This point is point Q. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, OQ is the radius of the circle that is equal to 2 units in its length. Here we actually implemented rule 2. Repeat quickly on rule 2. According to rule 2 is true in any circle. So in any circle, if chord AB intersects with chord CD at point O, then the following equation will be true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule 11 in our drawing. Why? Because in our drawing, we have chord AQ. This is chord AQ that intersects with chord CP at point D. Again, chord AQ intersects with chord CP at point D. Repeat again, in our drawing, we have chord AQ intersects with chord CP at point D. Therefore, according to rule 11, the following equation will be true. That AD times DQ equals to CD times DP. Again, AD times DQ equals to CD times DP. And again, according to rule 11, AD times DQ equals to CD times DP. AD is 1, DQ in total equals to 1 plus 2, that is 3, and it is equals to CD. CD is the missing side, so we leave it as it is, times DQ. DQ is square root of 5. So in total, we found out that according to rule 11, 1 times 3 equals to CD times square root of 5. 1 times 3 is 3, so 3 equals to the square root of 5 times CD. Here we divided this equation by square root of 5 and finally found out that CD equals to 3 over square root of 5 units in its length. This is side CD, and it is equal to 3 over square root of 5 units. In the next step, I copy this right green triangle DCB in a new page and implemented the Pythagoras theorem of this right triangle DCB in order to find out the missing side CB. Actually, this is the right green triangle DCB that I copied from the original drawing. We just now found out that this equals to 3 over square root of 5 units, and we already found out that the hypotenuse DB equals to the square root of 5 units. According to the Pythagoras theorem, this right triangle DCB, DB square equals to DC square plus CB square. Again, DB square equals to CD square plus CB square. DB is square root of 5, therefore DB square is square root of 5 squared, that is 5, plus CD square. CD is 3 over square root of 5, therefore CD square is 3 square, that is 9 over square root of 5 squared, that is 5. So in total, 3 over square root of 5 squared equals to 9 over 5 plus CB square. Here we substitute 9/5 from this equation and finally found out that CB square equals to 5 minus 9/5. Here we multiply this expression by 5 by 5 and then we divide it by 5 in order to become a factor of 9 over 5. So in total, after multiplying 5 by 5, in the numerator we have 5 times 5 is 25 minus 9 over 5. 25 minus 9 is 16, so in total this expression equals to 16 over 5. So CB square equals to 16 over 5. Here we took out of this equation and finally found out that CB equals to the square root of 16, that is 4, over square root of 5. So this side CB of the green right triangle DCB equals to 4 over square root of 5 units in its length. In the next step, I copied this right green triangle in a new page, and we found out the area of this screen right triangle DCB. That is the area that we are looking for in this question. Actually, this is the right triangle DCB that according to the original domain. We already found out that side CD equals to 3 over square root of 5 units, and we just right now found out that CB equals to 4 over square root of 5 units. This right triangle DCB, we have to find out the area of this right triangle DCB. What is the area of any triangle? The area of any triangle equals to the base of the triangle times the height to the base over 2. The height not raised, 19 raised with the base. So we choose the base as DC, and therefore the height of the base must be, actually we choose the base as DC, and the height of the base must be BC. Why? Because BC creates 90 degrees with the base DC. This again equals 90 degrees. So the height, the base is DC, the height of the base is BC over 2. DC is 3 over square root of 5, times CB is 4 over square root of 5 divided by 2. Here 3 times 4 is 12, over square root of 5 times square root of 5 is 5, divided by 2. 12 over 5 over 2 is 12 over 5 times 2. So it is 12, and 5 times 2 is 10. So in total, the area of the green shape equals to 12 over 10. We divided both the numerator and the denominator of this number by 2. 12 over 2 is 6, and 10 over 2 is 5. So actually found out in conclusion that the area of this green shape equals to 6/5 square units, or in terms of numbers, it is equals to 1.2 square units in its length. Okay, thank you very much.